Great, folks. In today's video class, we will talk about chapter number 2.2, in which we will talk about the stem and leaf plot. And after that, we will talk about the ungrouped frequency distribution. And then we will talk about the grouped frequency distribution. And then that will conclude the chapter 2.2. Now, stem and leaf plot, it's just a different type of a table in which we can sort out the data, and it helps us in reading the data in an easier way. That's what we can say. It's just another method of reading the data. So here we are given some data collected by the researcher. He collected data on the air fryers, and the prices of the air fryer from 2018 popular study is given to us down here. So whenever you are working on the stem and leaf plot, first thing you need to do is to sort out the data from smallest to the largest. So select whole of the data, and then you can right click onto it and then sort from smallest to the largest. In this, luckily the data is already sorted out, so I don't need to sort out. But when you're in exam, the data might not be in the ascending order, so always sort the data in the ascending order. So that is the step number one. You can note it down, please. Now, this is the representation of the stem and leaf plot. In this one, how to create the stem and leaf plot. So you can always select one of the columns here, and then you can minimize the width of the column, and that's how it kind of becomes a tallish building here. And then you can fill this section in with the color. You can go here, home, which will give you the segregation between the tens place and the ones place value. Generally, the values on the tens place will be on the left hand side, and the values on the ones place on the right hand side. That's how it's going to look like. And this data majority of the time will be 2-digit data. If there is a 3-digit data, then so something like 100, if I talk about, which has a 100 place also, so this is going to become 10 down here. So it starts from 4. So I put 4 here, 5, 6, 7, 8, 9, 10. Okay, I'm gonna make it here also. So I'm gonna start with 4 and 5, 6, 7, 8, 9, and then 10 here. Okay, so we've created the stem, and then this section I'll create a bar between the stem and the leaf. So here, home, I'm gonna fill it with some sort of a color, maybe bluish color I'll fill it with. And then whatever values are on the ones place, I'll start writing them on the right hand side. So this is starts with the 7. So 7 here, then 9 here, then 50. This is 50, so I'll place a 0 here. And then down here 51, so I'm going to place 1 here. Then I'm going to place 8, and then that's about it. And then if I see the next one is 64, so I'm going to place 4 here, and so on and so forth. 4 here, and then 5, and then 5 again, because 5 is repeating itself twice. And then we're gonna pick up the 9 here, 9, and then the next number is 70. So 70, so it will be 0 here, 1, and then 5, 5. So I'll put the 5 twice. Okay, and if it was repeating itself 3 times, so I'll put the 5 3 times. So then 8, and that's about it. And then 80, so I'll place 0 here and 0 here, and so on and so forth. So you're gonna end up getting a table something like this. So that's how uh, the stem and leaf plot is generated uh, for a given raw data. All right, now let let's see if there are any questions in this one. No, there are no questions. So we've created the stem and leaf plot. And if you were asked certain questions, you could have answered those questions based on stem and leaf plot. So I'll highly recommend you to do a couple of questions from the book on the stem and leaf plot. Now let's look into the more important ones, which is ungrouped frequency distribution. So basically what we are doing is we are given some sort of a raw data. The numbers are given, as I said earlier also, when you are given certain numbers, that's called the raw data. Now we're going to put it into the tabular form. So first one we're going to try and do is to put it into an ungrouped frequency distribution table. So ungrouped frequency distribution means just simple table, something like this one. where you are given certain numbers and how many times that number is repeating itself. That's called ungrouped frequency distribution table. So again, first thing I need to do is this data which is given to me, I need to sort out the data. So here, down here, I've sorted out the data, and then I will see what is the smallest number. 19 is the smallest number, and then the highest number is 24. So 19, 20, 21, 23, 24. I've written all those numbers here. Then I will see how many times 19 is repeating itself. So you can count it also if that makes it easier, but I've used the command here, COUNTIF, COUNTIF. So I'll show you here how I've used it, equal to count if, and then range is, this is the range I've selected. So always make sure you take the absolute reference of the range. That's going to help you to find the rest of the values easily. So what we are looking for, we are looking for the number 19 or whatever is in this cell is. So I'll select that one, and then I must make sure the range, I take the absolute reference so that when I start working onto it, it doesn't move. So Fn F4, I pressed enter, and then I'm gonna move it down below, something like this. So we got the numbers. If I won't have taken the absolute reference, see what's gonna happen. So if I select this one, if I don't take the absolute reference, so it was Fn F4, one more time. So this doesn't have any absolute reference. So see what's going to happen here. You may end up getting some right results, but not always. So so here, if I see if I used, see the data is also being, the range is also moving one step down. So because I sorted out the data, so these results came out to be the same. But if the data was not sorted out and I would have used the raw data, and then I won't have got the right numbers here. So hopefully you understood why we need to sort the data out and why we need to use the absolute reference of a given data. All right, so here this is the age given to me. 19 is repeating itself 11 times, 20 is repeating 8 times, 21 is 4 times, and 22 is 5 times, 23 is 2 times, 24 is 3 times. So that's what's given to me. And we've created the ungrouped frequency distribution table from here. That's pretty much it for this question. And total values are 33. If I see down here, yeah, there are 33 values starting from 4 goes up to 36. Now, how to create the grouped frequency distribution table. Now, grouped frequency distribution table, it means we are creating the classes. Classes means we will sorting out the data from the smaller sections. So here, down here, we are given certain data. The data shows the distances in the kilometers traveled by the 30 college students to the school. So this is the data given to me, which is being traveled by the students. Again, first thing I'll do is I'll sort out the data. So down here, I've sorted out the data, and from in the ascending order. Once I sort out the data, then I need to look for how many classes do I need to generate. And second thing I need to look for is the class width. So what is the class? Class means, so how many, this is one class, second, this is second class. So 0 to 4 is 1, 4 to 8 is second, and then 8 to 12, these are classes. So how many classes do I need to generate? The classes you need to generate is the very first formula on your formula booklet. That is given by this formula, 2 raised to the power n has to be greater than k. K is the number of data points, and n is the number of classes in this one. N is the number of classes in this formula, and k is the number of data points. So k, how many data points are there in this case? If I see carefully, the number of data points are it goes from 9 to 36. You can count the number of data points also. If I put equal to count, I will just use the command count, and oopsie, what's happening? 1 second, let me redo it. Count, yeah, it's automatically taking it. That's good. AI is smart. Oh jeez, what's happening here? Let me just delete this one more time. Equal to count K9 to K38. Well, it's counting down here, I see. So it's counting these values, not there. So all right, I'll use that one. So 30 data points are there. Okay, and now in total I must create the sections. I must create the number of classes based on these 30 data points. So 2 raised to the power n means 2 raised to the power. Let me just see if I can write it also. Insert or draw. Oops, draw. If I start writing on this one, so 2 raised to the power n, 2 raised to the power n should be greater than k. K is 30 data points. 2 raised to the power what is greater than 30? 2 raised to the power 5 is greater than 30. So the minimum number of classes I require is 5. So 5 classes should be there. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5, 6. I've created 6 classes in this section. So, but the minimum number of classes you require is 5. Okay, you can always go more than whatever the minimum requirement is. All right, let's look into how we're going to decide the class width now. So decide the class width, this is the formula we will be using. Highest value minus lowest value. Highest value is 23.4 here, if I see, and the lowest value is 1.5. Oops, say 1.5 divided by the number of classes. So highest value is 23.4 minus 1.5 divided by the number of classes. The number of classes in this case we've already decided we can have 5 classes. So if we do the math here, let me do the math on the Excel itself. So equal to 23.4 minus 1.5 and divided by 5, that is 4.38. Now 0.38, it is really complicated to take the 0.38. So what I'm going to do is I'm going to round up this number. I'm going to take a class size of 4. Okay, and lowest value, because this is 1.5, you can start the lowest value from 1, you can start from 1.5 even, but make sure this value should be incorporated. You cannot start it from 2 because then you won't be able to include 1.5. So start with anything which is a little smaller than this one and try and start with the whole number. We'll try to keep these numbers as the whole numbers because that makes our life easy. So starting from 0 and max, the highest number, because the class width I've taken is 4, so 0 to less than 4 I've taken. You can also include 0 and equal to 4. If you include equal to 4, then this number down here has to start from the 5. So remember this thing, if I end up using less than equal to here, less than equal to something like this, then this number has to start from 5. Now because I put it as 0 less than 4, and then here I have to put the other number as the 4 to 8, then 8 to 12, third class, 12 to 16, then 16 to 20. Do I finish at 20? No, I go beyond that, so I must add one more class, 20 to 24. All right, so these are the number of classes we've generated. Now how are we going to count it? So we're going to use this formula to count the values. So again, I've taken the absolute reference of my work, absolute reference of the range, and then now I'm using count ifs because I'm using more than one command, and this means more than one criteria, a smaller value and the greater value also. So value has to be greater than equal to 0. So that's what we're going to include, greater than equal to 0 and less than 4 because 0 must be included, and press enter. So these are 2 values, and then here down here greater than equal to 4 and press enter, and less than 8, greater than equal to 8 and less than 12, and here greater than equal to 12 and less than 16 And down here also, let's see, greater than, here not 16, it has to be greater than equal to 16 and less than 20. And from 20 to 24, again we will do the same, greater than equal to 20 and less than 24, and that gives me 30 data points. So this is how we've created the grouped frequency distribution table. The previous one was ungrouped frequency distribution table. This one is grouped frequency distribution table. So that's how we create a grouped frequency distribution. So that's about it for this class, and I'll highly recommend you to do certain questions from the book. Uh, Try and create especially the grouped frequency distribution table, because you will be using these grouped frequency distribution table and also the ungrouped frequency distribution table in chapter number 3. All right, that's it from my side for this class. I'll see you with the chapter number 3. Till then, goodbye.